Welcome. My name is Marcel. I am the author of the Mockifer library. This is not so much a tutorial, but a bit of a guided walkthrough of the core engine component of Mockifer, which most of the time you don't really need to do much work on, if any. You just have to be able to build it at least one time. But it kind of, sometimes it's nice to know how things are actually working under the hood a little bit. And, you know, if you did want to extend the default implementation of the core engine, you just need a little bit of C or C++ ability. It's not too hard. So hopefully I can walk you through how some of the core engine is built and how it all hangs together. So in the repository files for Mockifer, under the source folder, this is where all the products get built from, of course. And in particular, there's a folder called engine. And under that is all the C and C++ code that forms the core engine that gets compiled and then sort of included in all the other targets. So it's in a way, it's the brain, and it actually hosts the HTTP web server. So it receives the actual requests, and then it does a little bit of calculation to work out what route to apply for the requests, and it's also responsible for communicating in and out of the JavaScript virtual machine. So the way that the project is set up is that this engine folder with all that source code is here, but all the other targets that get built, like Android, iOS, the editor, and the console application, and of course you could make other applications as well, they all refer to this folder through reference. So they include the source code, but they don't sort of take a copy of it, they all just reference it. So what I'm going to do is just walk you through each of the targets that we build to see how they integrate this code, and then I'll show you how some of this code actually works. So we might begin with the editor project. So this is the desktop application that allows you to edit all the routes. And this is it here. It's just an Xcode project targeting Mac OS. And over here on in the coding section, you'll see that there's a Mockifer group here. And here is the engine, and it's a reference to that folder that I mentioned. Now, along with the engine, there's a tiny bit of glue. So this is how the interop happens between the target platform and the C++ code. So inside the editor, the editor is not something that you drop into other projects. It's a standalone thing, but it still needs to be able to interact with Mockifer. So you can see here some commands like start, reset, stop, push mock, create route, delete route. And some of these methods are actually not available through the iOS and Android libraries themselves. They're more administrative sort of tasks, so they're just shown in here. And then what you'll find is that there's a tiny bit of glue code written in Objective C++, which means that you've got a bit of Objective C, but then ultimately, like here, you're calling into C++ directly. And because of the way the Apple toolset works, it's actually quite easy to do that, talk in and out of those two platforms. So that's kind of nice. So that's the editor application. So if I hop over to this, which is actually the iOS framework that gets built. You can see here again we've got engine, so it's the same source code linked in again by reference, and it all compiles in as part of the target. And here, this mockifer.h file is what an iOS application has access to through the framework when it is running. So you can see here there's a similar set of commands as you saw in the editor. Few that are not here, like the deleting and creating of routes, that sort of thing. We just want to put things that can be consumed in here. And then similarly here, we've got some Objective C++. So it's just a very small little bit of glue code that sits between the C++ engine and Objective C or Swift. So this turns into Swift code if you're calling it as well, as you've seen in previous tutorials. And you can see here we're calling directly into C++ as well. So just a mix of that. Let's hop over to the console program. So again, this is a console application, which means it doesn't have a GUI, but there you go, it's exactly the same code linked in. So it's just compiling the same set of code, no difference. And in a console application, it's not Objective-C, it's just pure C and C++, more or less. So we don't need the bridging stuff. And then we go over to Android, which is just a little bit different. So this would look familiar if you have watched the tutorial on editing the JavaScript application, which would have been that. But I mentioned in that tutorial that there's this Android project in here as well. And this is what builds the Android.aar library. If you expand that out, there's a couple of interesting things in here. Under the engine, you can see here, this is actually the same code again. And the way that's included, if you look in the configuration for the Android project, down here somewhere. Sorry. So we're dealing with NDK now. So the way NDK works out what files to include for the C++ side of things, it uses a CMake lists text file. So it's a little more work to glue this stuff up together in Android than Apple products, but it's not too much. So pretty much this CMake lists text file, it says, look in those folders to find my header files. And then it says, these are all the implementation files, CPP or .c files to include with the compilation. So all these ones here are in that engine folder. So again, in reality, this is actually just a reference to these folders. I haven't copied this code into the Android project. It's still referring to it, which also means that if you make changes to these core engine source files in any of those source targets, all the other targets will get those changes as well, which is actually pretty good. So for Android, there's just a tiny bit more. So it needs to have some JNI methods written, and that allows Java to talk to C++ and potentially the other direction as well. So if we said, I want to start the server, we would expose some sort of a Java method with the signature, and it would internally call the C++ code. You don't necessarily have to worry about this stuff, but if you are going to make changes to the core engine, you probably would need to know about this. And then over here, this is actually the Java version of the API that you would talk to within an Android app. So you don't talk directly to that C++ code, you talk to this class here, Mockifer. And as an example here, we're loading up the that C++ library when it starts up. And here are those methods that you would have seen in previous tutorials, like pushing mocks or resetting the server. And what they really do is call through to the native equivalents. So these are just these native methods here, which if I have a look at that one there, or maybe the reset would be a good one. So native reset server, because it's annotated with the native type there, it really maps over to here with where's reset? Here it is. So the way it works is, if you've done JNI, or if you haven't, it looks for the package Mockifer, a class called Mockifer, and a method called native reset server, and then it delegates that code to the C++ side of things. So that's how the Android library is configured to be able to build all the C++ code. And just popping over to the Gradle there, this is how you activate that CMake lists file that I mentioned through CMake, and that's what causes all this code to appear in Android Studio. If you didn't have this, you wouldn't see any of these source files here. You can see it's listed down here. And this is just a little bit of configuration about telling how to build that stuff. So in the code I've written, I'm using C++ 11 code. I'm by no means an expert C++ programmer, but there's some nice things in C++ 11. I don't know if I can go higher than that to some of the later versions of C++ and still get cross-platform functionality, but you're welcome to have a go at it if you're better than me at writing C++ code. So anyway, that's how it's linked into the target. So I thought the next thing I could do is just give you a very quick walkthrough of the core engine itself and what it does when a request arrives. So I'll probably open up the editor because it's just a nicer place to come and look at things. And normally what would happen is if you want to make changes to the core engine, you can actually do it within any of those targets I've just shown you. I've kind of found that if you do it within an Xcode project rather than Android side of things, it's just easier because when you actually make changes and run, it compiles and runs very quickly, whereas Android takes a hideously long time to compile NDK code. So I've done most of the development within Xcode, even though I do prefer IntelliJ, but oh well, that's the way it is. So just starting from the top, Mockifer core. I'm going to go through this pretty quick. It's really just to get a sense of what's going on. This is just a few common things that are used within the Mockifer library, a couple of namespace setups, that sort of thing. But the server itself is where all the action happens. Don't really need to know about the header so much, but in the server implementation, what will happen is whoever is creating a new instance of the Mockifer will have to pass in the content path, which kind of resolves to that over here in the products we have the JS, Mockifer JS. That's what it's asking you to provide, because it will look in the folder for things like the routes JSON and the manifest and the API and things like that. So that's what that's for. The port, pretty obviously, is what port will be hosted when the service starts. So when everything begins, it will, bear with me, start server. When the server begins, it does a few things, and pretty much this is the flow. It will ask the routes manager to reload any routes that it might need to do. That would go and fetch that routes JSON that I showed you. And then we create the JavaScript virtual machine, and this is how it's done. So I'm using the duct tape library here. I'm not going to explain how duct tape works necessarily. Go and read the documentation on duct tape. It's a pretty amazing library actually. But that's how we create a brand new instance of it. And then we're going to do a couple of things. We're going to register these methods within the JavaScript virtual machine, and that allows our JavaScript application later on to be able to invoke them, and it links them up to internal methods here. So if I were to look at this load data file, what we're saying is make this load data file method available in JavaScript and map it to this method here. So if I just link through, that's actually, I'm still in the server CPP file, but that's a C method here. And this guy just says, okay, I'm going to grab whatever strings on top of the stack of the duct tape machine, which would be the file that you want to load if you look at the method signature. And then the rest of this is just loading whatever that file is, or attempting to, and then pushing it back into the JavaScript machine, which effectively is like returning a value to whoever called it. And of course, if something went wrong, we'll just push null instead and log an error. And then it's up to the JavaScript application to handle the error condition. So in our case, it probably resolved to being a 404 not found, or an internal server error, or whatever, however you want to do that. So I'll go back to where we were in the start server. So those are the methods. There's only actually 3 methods there that get registered. And then the next thing that happens is we load up all the JavaScript bootstrap files. So remember I said in previous tutorials that there's a file called manifest. Just open that up to refresh our memory. And it was pretty much a list of JavaScript source files that needed to be loaded or preloaded into the virtual machine as part of how the engine operates. So you can actually change this and put your own stuff in here, or if you don't want to use Kotlin, as long as you've got API.js, that's a core one, you can't change that. So we'll try and find out what files to bootstrap. If there weren't any, then that's actually kind of like a fatal condition. It means you haven't set up Mockifer correctly, or you've gone and broken the default configuration. You wouldn't expect that to happen necessarily. And then it just loops through them all and loads them into the JavaScript virtual machine. And what it does is it loads that code in, and it becomes then available to anything in that JavaScript virtual machine. So we're sort of warming up the VM. And then finally, what we're going to do is start listening on local hosts with whatever port we're asked to. This one here, num threads 1, we're deliberately setting the maximum number of threads that the internal server runs on, because we want to enforce the order of requests. So in a real web server, you'd probably allow many different concurrent connections. but we actually order matters for us. So we're limiting it to 1. And then pretty much this is what kicks off the web server to begin with whatever configuration you've asked it to do. And it will be attaching itself to this thing called server callbacks. So the server callbacks are referenced here, but ultimately at the end of the day, what happens is when a request is coming in, this method here will be invoked automatically by the server web, well, the way we've wired it up anyway. It will come into here, say, here's a connection, there's a request that's come in, you've got to do something with it, well, if you want, I suppose. And then we do a couple of things. We look at what is in the body of the request and decide how to respond. And the way we decide what to do to respond is we have a process request method here. And I'll just hop down. So what goes into that process request is the information about the request itself. And if there was a request body, which you would have for a post or a put, it sends that across as well. So if I hop over to the process request method, which is just down here, we create an actual request object, which is another class in here. I won't show it now. You can have a look at this later. But basically, it turns some blob of request data into a formal class object. And then that means we can ask that request things like find a matching route for that request, which goes through this thing called a routes manager, which I'll just show you briefly in a minute. And then we will have a route, or not. It may not have a route. And what happens here is we ask the JavaScript virtual machine to invoke this method, handle server requests. And remember that API JS file, I didn't really want to open Visual Studio Code, but anyway. And remember in a previous tutorial I said there's this method, it's part of the contract. So this here is actually the point in time where the core engine is calling out to that method, passing the request and the route as a JSON representation, because it's the easiest way to pass data in between different technology stacks in this case. And this here would actually be calling into the Kotlin code and returning the result. And so that's what's happening here. We're invoking this method, we're pushing these two parameters, because this thing takes 2 parameters. Okay, and then we're getting the response, which that gets the return coming back the other way. And then we do a little bit of logic here in terms of whether we're supposed to simulate a laggy response and lag if we have to. And then we return whatever that response was that ultimately came back from the JavaScript VM. And that would land us back up around about after this line. Now during that period of time, you know, things could happen. Maybe the server was killed. So we still just need to do a final check here to see if the server's still okay. And then from that point, we take whatever that response was. We set up some basic response content, and feel free to come in and manipulate this and adjust it to your own needs if you want. Add all the headers that should come back, and then we'll write out the response body, which would have been the thing delivered back from the JavaScript virtual machine. And that's actually what sends the response back to the caller. And that's pretty much it. That's the end-to-end flow. There's lots of other utility type code in here you're welcome to have a poke around in. The other interesting class that's in here is the route manager. So in the route manager, it has a few utility methods, but the one that's probably most interesting is this one, find a matching route. So it says, if you give me a request, I'll try and find you a route. And so if we find this here, find matching route, here we go. So very quickly, we'll be given some sort of request by the core engine. First thing we'll do is try and consume an active mock, which is if we had pushed a mock first, which may or may not result in something that's a valid result. If there were no active mocks, then that would not be true, and then it would fall down to the next part. And then it will iterate through all our internal routes that have been registered, and for each one see if it's a match. And as soon as it finds a match, it will break out. But If it finds a match, then the last thing it might do is again try and consume an active mock, but that might be waiting, that has an override ID. So that was a special route property that I mentioned in a previous tutorial. And this is the point in time where we kind of know what route we want internally. This is the last chance to check whether we should actually hijack it with a different route instead. Otherwise, that's what will come out of it. We'll get a route out of it. And the matching code itself is down here. I kind of talked a little bit through this when I was walking through all the fields that you can enter. I'll just very quickly skim through this. So we check for the request method first. We check the regex pattern for the URI. Then we do if the query string is supposed to contain a value, we check that. If it's supposed to equal a value, we check that. This part here is probably a little bit interesting. This is where we crawl that JSON body path if there is one. And maybe just come and look at this code if you want to learn more about how it works. It'll take me too long to walk through it in this example. But anyway, that's kind of how it functions. It might look a bit daunting, but there's actually not a great deal of code in here, to be honest. There's just a few key things glued in the right place in the right way to make all this hang together. And if you don't need to do any work on the core engine, you don't actually really need to know about any of this code, which is kind of nice. You can just focus on the JavaScript engine and application and leave all this to the side. So anyway, that was just a quick walkthrough. I just want to show you, the magic behind the core engine, so it didn't seem so mysterious. Like I said, I'm not sort of a world-class C++ developer, but I think the code in here is okay. It definitely does the job. Cool. I hope that was helpful, and that kind of gives you a rounded out view of the Mockifer system almost end to end. One thing I would mention is that you really only need to build the core engine once. I think I've said this in a previous tutorial, and remembering that forms these products. So an AAR file for Android, for iOS there's the framework, and once you built those things once, you could put them in your own application, and you really don't have to do that again. Unless you come in and sort of edit the code under the core engine itself. So just a bit of a reminder about that. Okay, well, thanks for watching, and hopefully you find this library useful.